Okay, so the last example here, we're looking at a Ferris wheel and Trevor's height above it. Again, because it's the wheel over time, that's going to create a periodic function to go up the wheel, then down the wheel, then up the wheel, then down the wheel. As long as the Ferris wheel doesn't stop or change speeds, it will be the exact same function every single time. Okay, some things we want to do, some problem solving. I want to find the period of this function and figure out what it represents. So the period, we start here, we end here. Part A, our period would be 8, and in this case it's seconds. What does that represent? Well, it's the time to go around the wheel once. That'd be a pretty fast Ferris wheel, but that's besides the point. Okay, part B. What is the equation of the axis? It doesn't say the word central in there, but we always assume that the equation and axis means the central axis. Okay, so my central axis is y equals my max. I look at my graph. My max would be 7 plus my min. That's 1 divided by 2. So we get 8 over 2, which is 4. And it doesn't ask us for it, but that would be our average height, right? Or if you think about it on a wheel, and that'd be where the wheel, the center of the wheel would be mounted, right? The halfway point on that wheel. Okay, part C, what's the amplitude? Our other big property we looked at today. Our amplitude would be our max minus our min divided by 2, which is 6 over 2 or 3. Again, it doesn't ask us for it, but if you thought about this, the distance here or the distance here is 3. That's the distance from average. That'd be the radius of the wheel, right? How big that wheel actually is. Kind of a handy thing we can figure out from a periodic function. D. After 24 seconds, when will Trevor be at the lowest height again? So we notice he's at the lowest at 0, and then 8, and then 16, and then 24. When's the next lowest height going to be? Well, using our idea of periodic and repetition, if I were to write down 0, then 8, then 16, then 24, these are all following the exact same period, right? The next ones would be 32 and 40 and so on and so on. They're going up by that 8-second period every single time. Okay, part E. At what times is he at the top of the wheel? Well, I can see the first one. There's 4. Common sense says if I keep adding 8, I should get the next ones. So 4 plus 8 is 12, plus 8 is 20, plus 8 is 28, and so on and so on and so on. And I can check the first couple, right? 4. And sure enough, the next one is at 12, and the next one is at 20. I can't see the next ones, but I know because of my patterns, that's what they're going to be. And the last part, when will his height be 4 meters between 24 and 30? Okay, so we know this graph will keep going up like this. 24 is right here. 30 is somewhere over here. I want to know when he's going to be at the height of 4 meters. And logically thinking, he's going to be at 4 meters. Let me look at this graph. On the way up, and again on the way down, right? So we have to figure out the 2 times. Okay? On the way up would be 8 seconds after the last time on the way up. So 18 plus 8. Okay, so on the way up, okay, 18 plus 8 would give us 26 seconds. That's when he hits 4 meters. And on the way down, well, I think the last time he was on the way down, right there, I add 8 to that, it would give me the next one, right? So 22 plus 8 on the way down. 22 plus 8 would be 30 seconds. And we can keep adding 8s to those if we want to figure out any other times where he's at 4 meters. Okay, and that's the end of periodic functions. No quiz today, just try the homework questions. It's a little sheet you can look at and check your answers.